What if your most important source of protein didn't come from the field, but from the water? No vast farmland, no monocultures, no global supply chains. Just a plant that grows and keeps growing. Maybe it's small, maybe it's inconspicuous, but maybe that's exactly its greatest strength. Because if protein were no longer tied to land, it would change everything. What if protein didn't automatically consume acreage? What if food security didn't have to be linked to land prices? Why do we accept as normal that high-quality plant proteins require massive agricultural areas? And what happens when a plant shows that there's another way? Welcome to Rooted. We ask questions and search for answers that can truly be applied in practice. Here, we open another chapter of agriculture that didn't fail. It simply didn't fit the industrial model, and we decide whether to make use of its value. Today, we're exploring ideas that didn't collapse. They just never fit into the industrial framework, and, in part, we're challenged because of it. These are exactly the discoveries that fascinate us every day. Today's focus is a plant that can double in size within just a few days, that has been described in studies as protein-rich, and that can theoretically be cultivated in closed water systems. Duckweed. Why is that relevant? Because plant-based protein has become strategic. The Food and Agriculture Organization, FAO, projects a significant rise in global protein demand by 2050. At the same time, arable land is becoming scarcer. Climate change, soil degradation, urbanization, more demand, less land. And here lies the critical point. Most protein crops grow on land. This plant grows on the surface of water. That's not a detail, that's a structural difference. We're not just talking about a plant. We're talking about whether protein production must be tied to soil at all. Duckweeds are tiny, free-floating plants. One of the most frequently studied species is Lemna minor. What makes it remarkable is its growth dynamic. Unlike soybeans or peas, it grows continuously. No sowing, no waiting for flowering. No months-long cycles like soy or peas. Under good conditions, its biomass can increase significantly within just a few days. That doesn't automatically mean record-breaking outdoor yields, but it does mean extremely short production intervals. And this biomass isn't empty. Depending on the species and cultivation system, the protein content can fall within a range comparable to traditional protein crops. That's not a claim from online forums, it's the subject of scientific research. Imagine two systems. System A, you need land, seeds, fertilizer, harvest cycles, transport, storage. System B, a plant grows on water, reproduces itself, and is partially harvested on a regular basis. Duckweed has one of the highest relative growth rates among flowering plants. Nearly all of its biomass is photosynthetically active. No stems, no wood, no energy loss through elaborate structures. Almost every cell produces. That is biologically efficient. In addition, no plowing, no soil erosion, no humus loss, no soil compaction from heavy machinery. The system works additively, not destructively. At this point, I remember thinking, how incredible is this? Why have I barely heard about it? Here are the reflections that made me pause. This is why the topic is structurally powerful. It produces protein without consuming soil. That's a quiet revolution against land dependency. Let's look soberly at soybeans. 1 hectare of soy yields, depending on the region, about 2 to 4 tons of beans annually. That equals roughly 0.8 to 1.2 tons of protein per hectare. But soy requires arable land, crop rotation, often pesticides, mechanical harvesting, global transport chains. Around 80% of the global soybean harvest ends up as animal feed. Duckweed produces plant protein directly. No detour through livestock, no barns, no feed conversion losses. Under controlled conditions, studies have described significantly higher protein yields per area than traditional field crops, though in optimized systems. The difference isn't just quantitative, it's architectural. Soy is a soil-based system. Duckweed is a surface-based system. Soy is seasonal. Duckweed is continuous. Soy needs new seeds every year. Duckweed regenerates vegetatively. This isn't replacement, it's diversification. And diversification means resilience. At that point, I felt a certain discomfort. Let's run a thought experiment together. 10 square meters of soybean cultivation. In a temperate climate, that might yield 2 to 4 kilograms of beans. That's roughly 0.7 to 1.5 kilograms of protein. Now imagine 10 square meters of controlled water surface with duckweed in an optimized, continuous system. Studies suggest that under ideal conditions, significantly higher biomass rates per equal area are possible compared to soy. Important, these are laboratory or pilot conditions. Not every backyard pond will achieve those values, but even conservatively calculated, the productivity per area can be competitive with completely different resource use. And that is decisive. Not just how much, but how. Let's go deeper and talk about dependency. Protein is already geopolitical. Soy imports are strategic dependencies. Trade conflicts influence feed prices. Fertilizer prices depend on natural gas. Whoever controls protein controls food systems. That's not theory, that's reality in international agricultural policy. Decentralized, water-based protein production wouldn't eliminate dependency, but it could reduce it. If parts of protein supply can be produced locally, the system becomes more robust. And robustness means stability and power. Duckweed can grow in closed, clean containers. Not in open water, not uncontrolled, but in clearly defined systems. You harvest part of it, the rest keeps growing. As long as light and nutrients are available, the biomass regenerates. This isn't mathematical infinity, but it is a regenerative cycle, and regenerative cycles are strategically valuable in times of rising input costs. No wild harvesting, no removal from polluted waters, no release into natural ponds. Duckweed can accumulate contaminants, if used, then from verified sources, in closed systems, in compliance with regional regulations. One studied species is Lemna minor, but not every duckweed species is automatically edible or suitable. Knowledge replaces euphoria. Maybe duckweed will never replace soy, but I'll ask a radical question. Why do we still tie protein to land? Why do we define efficiency by acres rather than by cycles? Why do we prefer genetically modified soy instead of self-directed local production? A plant that floats, that grows, that regenerates, shows that dependency is not a law of nature. Maybe the real revolution isn't loud. Maybe it's green, quiet, and floating. Write your thoughts in the comments. The next episode of Rooted is coming soon. We're already working on it. Open, curious, and grounded in real-world practice.